the surface profile related to datum system. Belongs to the group of the location tolerances, which effectively control form, orientation and also the position of the tolerance feature. In this video I will explain how the tolerance zone is defined and how the deviation is calculated according to the ISO GPS standard. The drawing specifies a surface profile tolerance of 0.4 mm related to the BAC datum system, which consists of three perpendicular planes with orientation constraints between them. The arrow indicated the tolerance feature, called the theoretically exact feature. In the case, shape of a profile is defined by theoretically exact dimension, shown in rectangular frames. Another way to define them is by using, for example, a CAD model. The surface profile tolerance zone is established using spheres whose centers are situated on a surface having theoretically exact feature. Tolerance zone is limited by two surface formats by enveloping spheres of diameter equal to the specified tolerance value. This way of defining the tolerance zone makes it conform to the shape of tolerance feature. In addition, it has a constant width and is centered with relative to it. Datum system, which consists of three perpendicular planes B, A and C, removes all of 6 degrees of freedom. It means the tolerance zone is constrained by the three perpendicular planes and cannot to move or rotate relative to them in order to fit the real profile. In such a case, the UF modifier could be omitted. To better visualize the deviation, let's construct the tolerance zone once more, this time in an orthographic view. The calculation of the surface profile's location, deviation should begin with removing the degrees of freedom. The datums are used together sequentially in a given order indicated in the tolerance indicator. According to ISO 5459, this is done by simulating the contact of the real integral feature, the ideal element called a datum, with the non-ideal real element called a datum feature. In this example, the part is aligned by 3-2-1 method. The plane, defined by datum feature B, contacts the primary datum B at 3 points, removing 3 degrees of freedom. Next, the plane defined by datum feature A contacts the secondary datum A at 2 points, removing 2 degrees of freedom. Finally, the plane defined by datum feature C contacts the tertiary datum C at 1 point, removing the last degree of freedom. The reference element for evaluating the deviation is the theoretically exact feature surface. We already know that the tolerance zone is by default centered symmetrically around the theoretically feature. Therefore, the upper and lower limits are plus 0.2 on the material external side and minus 0.2 on the material internal side. The deviation is calculated using extracted points, sampled from the real surface. Positive values indicated material excess, while negative values indicated material deficiency. The total deviation is determined by the single point that lies farthest from the reference. In this example, that point is the plus 0.191. This value is always multiplied by 2 because the profile tolerance is expressed as the diameter of the sphere, not its radius. The surface profile deviation equals 0.382 mm. The easiest way to measure the deviation is by using a coordinate measuring machine with software that allows measurement against a CAD model. Reporting only the total deviation value doesn't provide complete information about the real profile of the toleranced feature. Therefore, it is also recommended to present the deviation of the individual extracted points graphically in the normal direction, that is perpendicular to the theoretically exact feature surface. This way of reporting provides a complete picture of the deviation, which makes it easier to analyze measurement reports and implement correction in the manufacturing process.